One of the great things about open protocols is that we can mix different devices on the same subnetwork. So if you have a BACnet MSTP subnetwork, you can daisy chain along that subnetwork, variable speed drives, BMS controllers, electric meters, thermal meters, a fire panel, a couple of chillers at the end. And since 2000 and moving forward, we have been getting more and more devices almost every year or every few years that now come default with BACnet IP or BACnet MSTP interface cards. And over the years, we've been connecting all these devices together. Now, although that technically works very well, if you're doing a very large project, you can run into problems. And usually when you find out you've got communication issues, it's normally too late. So normally you're in commissioning phase, you're powering up floors and plant rooms, and as you power up different zones, different areas, and more sub-networks come online and more controllers come online, you start to realize that your whole network starts to slow down and you start to experience communication issues. Now in this video, we're going to discuss why, especially on large projects, you should consider separating out your electric meters, your variable speed drives, and your BMS controllers onto 3 separate subnetworks. Now, if you look at the drawing here, this is a network drawing from the BMS design course. So I have already split up the networks. And you can see here we have, on trunk 1, we have 3 BMS controllers. On trunk 2, we have some thermal meters. Trunk 3, we have variable speed drives. And then we've got these 2 chillers here on BACnet IP and these 4 electric meters, or this whole trunk here on a Modbus R2 back to a gateway here. But for the purpose of this discussion, let's just assume that all of these are connected together. So on one BACnet MSTP subnetwork, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 devices, all daisy chained together along the RS485. Now here are the issues that we normally come across. The first issue is, how does BACnet work? So MSTP stands for Master Slave Token Passing. And this means that the master is usually the network controller, and then all the devices down are the slaves. So this token gets passed down the subnetwork, and only when you have the token can you communicate. So if you open up a graphic of a variable speed drive on the BMS server, and there's 5 points on there, that variable speed drive can only transmit that information back to the graphic to refresh when the VSD has the token. So if the token's coming down the run, it's got to wait, it gets a token, sends information, the token goes again. It needs to wait for the token to come back around again before it can speak again. So it's important to realize this token passing, because obviously the more devices you put down the subnetwork, the longer it takes for the token to get all the way back around. So although the BACnet MSTP protocol can be quite fast in how it communicates, the ones and zeros down the RS485, how the protocol actually works and how it deals with managing traffic collisions and the transferring of data, it can be a bit sluggish through that process. Now the next thing is that not all BMS devices work the same way. And you would have seen this already when you're looking at application-specific controllers or building controllers. They have different profiles and different sort of functionality within them. And one of the issues that I've come across is that most of the 2 main variable speed drives that we use here in Australia, they're default BACnet cards that come with them. So we're not talking about their advanced BACnet cards that you can sort of add in afterwards, just the BACnet card that comes straight out the box default. The BACnet MSTP card. Those interface cards do not support COV, Change of Variable. So what that means is the BMS needs to continually be polling the VSD to get information out of it. So if you have, for example, in your software program, have built a bit of logic in there that checks if the fan's running, then enable my temperature control loops and my pressure control loops. Well, every time that program runs through its instruction set, it's got to go out there and check the VSD. Are you running? Yes. Are you running? Yes. Are you running? Yes. And remember that the VSD can only send that signal back when it has the token. So it's got to wait for the token. Yes, I'm running. Token comes around. Yes, I'm running. Yes, I'm running. So Whereas if the VSDs did have COV as one of their backnet properties, then what would happen is in the morning when the VSD run status went from off to on, it was a change of state or a change of variable, it would say to the network controller or the controller, I'm running. And it would run the whole day, and in the afternoon when it was turning off, it would go from on to off, a change of state, change of variable. It would tell the controller, I've turned off. So that would be sort of like traffic going there twice. But because VSDs don't support COV in their default configuration, the BMS needs to keep polling. So as soon as you start using HLI information from a variable speed drive in your controller somewhere, it's going to dramatically slow the network down. The next thing is that variable speed drives don't support multiple read-write property. Now what that means is, again, if you open up this graphic and you've got voltage, current, kilowatts, kilowatt hours, frequency, speed, a whole bunch of points in your graphic, there's more than one point there. So when that graphic opens and it requests that information, the VSD is only going to update one of those things when it has the token. So as the token comes around, it says, here's my kilowatts, here's my kilowatt hours, here's my current. So although the trunk moves really fast, it's going to take quite a lot of scans to get through to update that one page. So the two issues there were COV and multiple read-write, and that slows your network down. The other thing we have is we don't just have the BMS server accessing data anymore. We have all sorts of other things now. We have energy management systems, which are often third-party systems, and we have building analytics, so they could be two cloud-based energy management systems. So, in the early 2000s, the last 20 years, it's generally been the BMS scanning for collecting data, sending out commands, time schedules, starting, stopping equipment. So you might have a building management system, an energy management system, and a building analytics package. All three of them are now polling through the network controllers down the sub-networks to collect information. So in this example here, where there's 4 electric meters on the end, you could have the energy management system every 15 minutes coming down and polling through to all the way down that sub-network. Collect 1, collect 2, collect 3, collect 4. That's the kilowatt hours every 15 minutes. And the building analytics package could be checking things from the BMS controllers, getting things from the VSDs, getting things from the electric meters as well. So we have multiple supervisory devices accessing data through the Ethernet and onto the subnetworks. Now, if you have a small project, then, and on the roof you have 2 electric meters, you've got 2 VSDs and 2 BMS controllers, it's a small job, it's a $200,000 job. Of course, you're not going to separate those devices. You just connect them all together, just as it's designed to do. But when you have a large project and you have 500 BMS controllers and 300 electric meters and 200 variable speed drives, you really need to start thinking about how you design your subnetworks. And as per this example here, we want to have our network controller, and we want to have one subnetwork going to BMS controllers in the panel in the plant room, one subnetwork coming off, running around the plant room, picking up all the variable speed drives, and then a third subnetwork picking up the electric meters in the mechanical switchboards, and going up the riser and picking up the lighting power meters up the floor. So we want to have 3 separate subnetworks. And that's useful because the energy management system is now coming through and polling its own subnetwork, collecting the kilowatt hours every 15 minutes. And if you have a lot of data going to variable speed drives, it's collecting to the variable speed drives. And if you have BMS stuff happening, changing set points, starting, stopping of equipment, status checking and stuff like that, that's all happening in its own subnetwork. So we're pretty much taking that long subnetwork with the master slave token passing, and we've separated into 3 subnetworks. So we've basically reduced the token can go 3 times on 3 different subnetworks. Now, another thing is, if later on through the life of this building management system, you want to upgrade your BMS, your controllers are obsolete and need to be replaced, that quite disruptive project of upgrading a few hundred controllers, it will not impact on the energy management system. Because while you're pulling these controllers out of here, the energy management system is polling through and getting the data from electric meters. It's not being impacted at all with you replacing controllers and powering down panels. Energy management is very important nowadays. If you have energy management systems missing some samples every 15 minutes, it can be quite dramatic and draw a lot of attention to the BMS. Also keep in mind that energy building analytics, their job is really to find faults in the BMS. That's what their job is. So it will very quickly start to find that you have communication issues or poor quality of data. One of the very first things that an analytics contractor does when they're engaged is the first thing they do a review of the BMS network, checking the speed and bandwidth and the quality of data. And they will always be issuing a report to say that they've got really bad quality data. And usually, in my opinion, it's because the sub-networks are overloaded and you have different vendor devices mixed on them. Now, just keep in mind that we're talking about one thing here that affects the performance of the BMS network. There's a whole bunch of other things. You need to have a good quality cable, and the cable needs to be the right type of cable for communications, not just the same cable that you're using for temperature sensors and valve actuators and damper actuators. The screen needs to be properly continuous throughout the daisy chain and not earthed at the controllers and just earthed at one place. Terminating resistors, the number of devices on the sub-network, that's been a discussion, but generally the RS485 rule is not more than 32 devices, although that's all changing. But the point here being is that there are a lot of things that are going to affect the performance of your network. This mixing multiple devices is just one of the issues that I'm having a little bit of a problem with. Now, if you enjoyed this video, you got some value, please like and subscribe. And if you have had problems with communications issues by mixing different devices together in the same sub-networks, please leave a comment. Otherwise, I'll catch you guys next time.